linear functions, and we're going to actually talk about the idea of linear versus nonlinear. So let's take a look at first a couple of problems that we've been used to seeing so far, and on our bell work, let's try them out. So this first one says, use a graph to write a linear function that relates y to x. So first of all, we look at the right here where it crosses the y-axis, which is the y-intercept, and we used to call that b. So b equals -2. And then we look at our slope. From this point to this point, we have to go up 1, 2, 3, 4. So up 4. Remember, this is our slope. The change in y over the change in x, which is 1, 2, 3, 4, 5, 6, 7, 8, which simplifies to be 1/2. So then our y equals mx plus b equation would be y equals 1/2, sorry, I almost said negative, but 1/2 x minus 2. So that would be the linear equation or linear function that fits this graph right here, okay? All right, the next one is the domain of this function discrete or continuous. Well, can you count the number of people who go to the movie or movies? So one movie costs you $9. That's going to be $4.50 per movie. 2 movies cost you $18. So actually, it looks like each movie's costing you $9. So $9 per ticket. So this would be a discrete function because you're just talking about the number of movies, you can count them, and how much the cost is. Okay, write the following equation in function form. That means we're just going to solve it for y like we have done so many other times. So to solve this one for y, we're going to move 3x to the other side. And we just put that around here. That minus sign actually goes with the 2y. So that means we have to subtract 3x from both sides. So we'll end up with -2y equals -3x minus 6. Then we're going to divide all or both sides by -2. So our final equation in function form would be y equals 3 over 2x plus 3. So we've done that several times, and sometimes we just said, write this equation in y equals mx plus b form early on, but now we're saying the same thing by writing it in function form, which is the same thing. All right, so let's move on. So we're going to be talking about linear versus nonlinear functions. A linear function, any function whose graph is a non-vertical straight line. So if the line goes like that, goes straight, curves down, or slants down, as long as it doesn't go straight up, that doesn't count. Any function whose graph of the data looks like this would be called a vertical, or excuse me, would be called a linear function. Meanwhile, a function whose graph is not a line, so such as if we graph it and it looks like this, that would not be a linear function. That would have some other name. Or if it went like this, or like that, that would be a non-linear function if that's what the graph looks like. Okay, so how can we tell if a graph or a function is linear versus nonlinear from a table of ordered pairs? Well, first of all, in order to tell if it's linear, we just find out if it's got a constant slope. So let's look at the change in x. In this step, we're going +2, +2, +2. In this section, the change in y would be up 9, Oh my goodness, then it's going up 22. So if you notice, then up 55, this is going up faster and faster as time goes on. So this would not be linear. This is non-linear. So that's how you tell from a table of values if it's linear or nonlinear, is if its rate of change is constant instead of ever increasing like this. So let's check this next one out. Change in x to go from -2 to -1, that's a bump up of 1. To go from -1 to 0, that's a bump up of 1. To go from 0 to 1, that's a bump up of 1. So far, our x values are changing by 1. What about our y values? To go from -4 to -6, that's a drop of 2. To go from -6 to -8, drop of 2. To go from -8 to -10, a drop of 2. So do you see how the change in y over the change in x is remaining constant? So if we graph these would line up in a straight line. So that's how you tell on that. Okay. Well, how can you tell from a graph? Well, you just look at the graph. You notice how this does not have a straight line to it? So that would be nonlinear. Now, what if you had some data points, if you graph them, and then you could see if they line up too. This one is a straight line, horizontal, not vertical. So this would be a linear function, because it is a straight line that doesn't go straight up and down. Okay, how about a linear function can be written in the form of y equals mx plus b. So you got y equals to some number times x plus or minus some number. So if you look at this one, this fits that form. There's m, there's b. If you look at this one, however, the x is in the wrong place. The x is below the number, so in the wrong spot. So this would not be this would be a nonlinear, because x is in the denominator in that spot over behind the equal sign. This one, that one has an exponent on it. You can't have an exponent on it other than 1, which is what this one has. So this would be nonlinear. That doesn't mean it isn't a function, it's just not a linear function. In fact, this has a very distinct shape. Now, if we look at this one, we can tell that if we just rearrange it a little bit, 5x, if we bring the 8 over and put -8 equals, and then put the y on the other side, it becomes positive y. So if you kind of look, we've got one of these slope-intercept equations just written backwards, and now we can just kind of flip sides so that they're just kind of reflected across the equal sign. And there's our slope-intercept equation. So this one would be linear. And so would this one. Okay. Okay, now we're going to talk about the idea of increasing, decreasing, or constant on a graph. So increasing means if you're looking at part of the line and the line is going up as you go to the right. Decreasing means it is going down as you go to the right. And constant would be if it's flat or a horizontal line. So on this particular graph, this first segment from A to B would be constant. From B to C, this would be increasing. This would be a constant. And then this section right here would be decreasing. So pretty straightforward on that. It's pretty easy, huh? Okay, now let's take a look at this. We've got 3 pumps that we're looking at here. Each one, the data has either been graphed or written in a table or written in a function. So let's take a look at the rate of change, or how fast each pump is pumping fluid. So this first pump starts out at 0, 0, and then in 1 hour, we notice that we've pumped 120 in the amount of our fluid. It doesn't say whether it's gallons or not. Maybe that means liter or something like that. So we've pumped 120 of these units in 1 hour. So 120 over 1. All right, so on the next one, we notice that the number in front of t, which is the rate of change or our slope, is 110 over 1. So we notice this one's a little slower than this one. And then in the last one, we notice that the change in x is 1. So plus 1, plus 1, plus 1. So every hour, how much is our fluid changing in liters? By 90, right? So the rate of change on this one is 90 liters every hour. The rate of change on this one is 110 liters every hour. The rate of change on this one's 120 liters every hour. So there's the three rates that we were talking about for question 1. Okay, what pump is the fastest? Well, pump A is, right? It's got the fastest rate of change. How much does each pump in 2 hours? So the first one, pump A, would pump 240. Pump B in 2 hours would pump 220. And pump C in 2 hours would pump 180. 180, and these are all liters. So that's a kind of a fun little question. And when we do our ALEKS assignment, we'll see some questions similar to that. Okay, here's another really classic ALEKS example. For each situation below, identify the independent variable and the dependent variable. So in this case, the x variable is the independent variable. So on this one, when you do this on ALEKS, you just click on this little arrow, which I can't do in this format, but it will bring up a little menu that says independent, or it'll say the number of hours worked or the number of necklaces made. So you'll just click on the one that has the x values in it. Then the other dependent variable in this case would be the number of necklaces made. So you'd want to make sure you identify that under here. Okay, how about this next one? Christine takes a certain medication. The table below shows how the amount she sleeps is affected by the amount of medication she takes. So if she takes 10 milligrams, she sleeps 8 hours. If she takes 20 milligrams, she sleeps for 7 hours. If she takes 30 milligrams, she sleeps for 6 hours, and 40 milligrams for 5 hours. So the more she takes of this medication, the less she sleeps. So what is the independent variable? Well, that would be the x's, so that would be amount of medication, right? Medication amount. Okay, then the dependent variable would be hours of sleep. So you'll just click on that little down arrow on ALEKS, and then it'll have a submenu that you can pick. It might not be worded exactly the way I've done it, but it'll be similar, so you can figure that out. So that'd be hours of sleep. All right. So your assignment is on ALEKS. It's entitled Linear versus Nonlinear Functions. And in a few cases, you're going to have to show a little work to determine the rate of change in the y and the x direction. So good luck, and thank you very much.